up, guys? We're continuing looking at these special segments of triangles. So we've looked at mid-segment, we looked at altitude, and we've looked at median. So now we're going to look at the bisectors of triangles. So we have a perpendicular bisector and an angle bisector. So we're going to look at the perpendicular bisector first. So by definition, the perpendicular bisector intersects one side of the triangle at a 90-degree angle, obviously perpendicular, and bisector also means it cuts it in half. So it has to be equal distance on both sides of that perpendicular bisector. And just like with median and altitude, we do have a special name for the intersections of all the perpendicular bisectors. On your notes, it says incenter, but it's really supposed to be circumcenter, as I have written here on the video. So you might want to change that real quick. But the circumcenter is the intersection of all the perpendicular bisectors. The circumcenter is also equidistant from every vertice of the triangle. So wherever the lines cross there, they will have a common factor, or they would, whenever we find that intersection point where the centroid, wherever the circumcenter is, that's going to be the same distance to every single vertex or vertice of the triangle. All right, so now let's look at angle bisectors. So by definition, that's a line segment or just a regular line or a ray. So all of those are encompassing. Usually it's just a line segment or it's just a line, but it can be any of these that is going to divide the angle into basically two equal halves, two congruent halves. All right, so just like I talked about before, on your notes it says circumcenter. That's supposed to be incenter, just like I have here written on the video. So the incenter is going to be the intersection of all the angle bisectors. Okay, and so now just like we have some other special work with the incenter, just like we have with the centroid and then with the circumcenter, this is actually going to be the same distance from the side at a 90-degree angle for every single side. So I'm going to put that into words. So here's what I'm talking about. So let's go ahead. I'll just cut these kind of sort of in here. Okay, so basically what that's saying, and this is not a very good drawing of this, but if this is the incenter right here, which if it were cutting all of them in half, and that's exactly where it would be, then making the 90-degree angle to this side, which would be about like this, and then 90-degree, oh no. Okay, so 90 degrees to the opposite side here, and then 90 degrees to this side here, and then 90 degrees to this side here. All of these green lines should be the same distance. Now, I didn't draw everything to scale, and so I may have some, since I just kind of sketched it, but all those green lines should be the same distance. So whenever they make a 90-degree angle with this side from the incenter, okay? So what we're going to do here is we're going to name the point of concurrency of the angle bisector. So where do the angle bisectors cross and what is it called? So the angle bisector, remember, cuts the angle into basically two congruent angles. And so it's going to come from the angle there. So we have this line here, which would be CP. We have B. We don't have another point on that other side. And then AS doesn't go in there and say it, but that's where it's going to be. So this right here is going to be called the incenter. And that is at point Q. That's of the angle bisectors. So you can see here that we have an angle bisector because if you look at this little arc there, it's the same for both angles here. That is just another way of saying that those two angles are congruent. They're the same measure. So if you ever have to look at that on anything else for geometry, if it has the same arc on two different angles, then they are congruent. They're the exact same measure. So I know that it did the same thing here, and it did the same thing for this angle bisector, for this there, because it has the two side links, so, or two little arcs there, and then you would do another one for like three, or sometimes you would see like a little arc with a tick mark through it. That again notes that those two angles are congruent. So therefore, this where they cross right here is going to be the end center. So I know that this line segment and this line segment, those are congruent. So if I'm trying to find the value for x here, I would have 2x is going to be equal to x plus 3. And then just solving for x there, I move my x over because I have x on both sides. So it just leaves me 1x, or just x, is equal to 3. Then if I needed to find the side lengths of each of those, or one of them is going to be equal to the other one, then I would just plug it in for x there. So 3 plus 3. So this line segment would be 6. So you've seen some questions like that. Sometimes it asks for x, and sometimes it asks for the line segment itself. So be very careful about when do you plug it in and when do you just leave it as x. All right, so we're going to solve this for the value of x. We're finding the value of x. I know that this point here is the end center because I know that this line cuts this angle based on the fact that it makes two congruent angles. And I know that this line cuts this angle here based on the fact that it made two congruent angles. So I know that this right here is going to be my end center. And because I know that the end center is the same distance in the perpendicular to the opposite side of every side of the triangle. So I'm going to go ahead and figure that out. So I have 5x minus 4 is equal to x plus 6. So I'm going to have to solve for x here. I'll start off by subtracting x on each side. So I'm left with 4x minus 4 is equal to 6. And then I will add 4 to both sides. And so 4x is equal to 10. And then I will divide each side by 4. And so x is equal to 2.5. So again, I could plug that into my equation there, into x, where those are, and wherever they are in the triangle, and then figure out those side lengths. So if I needed to figure this out, obviously all of them are the same. So this side length is going to be 2.5 plus 6, which is going to be 8.5. So that side length there is going to be 8.5, which means all of the other ones would be the 8.5 as well. But that's just, if it just depends on what the question is asking you. Is it asking you for the distance there, or is it asking you just to find x? And so therefore, that's what you would make sure that you are paying close attention to. So we looked at the bisectors of triangles. We have angle bisectors, which cut an angle basically in half. And then we have perpendicular bisector, which is going to cut a side length in half and make that line is going to be at a 90-degree angle. We talked about the circumcenter, which is the intersection of all the perpendicular bisectors. And then we have the incenter, which is the intersection of all the angle bisectors. So kind of, again, more growing our vocabulary with these special segments. And I think that this wraps up all of our special segments. So again, trying to wrap your brain around all of these and trying to put these all together, because that's how you're going to see them presented, is that they're all going to be chunked together. So just make sure you're paying close attention to what you're given and what you're being asked to find. And now it's your turn to practice with your skill check.